Welcome to Ryzen's Real Life Recipes. Here's one of my favorites. I have a volumetric flask here, and what I did is I heated up some water and I put it into this flask and put it upside down. You can see it's boiling a little bit right now, and I'm going to do something that is pretty amazing. We're going to let that stop boiling first, and then I'm going to use ice and make it boil. You'll notice there's water in there, and then there's air inside there, okay? Let's try it. What I'm going to do is I'm going to put ice. I got a beaker of ice here, and I'm going to put it on top of the flask, and I want you to notice the water inside that flask. Okay? See? You can see the bubbles? That's boiling. So we are officially boiling water with ice. Very cool, huh? Oh, well, it's supposed to be hot. So you may not think that water can boil below 100 degrees Celsius, but it can. In fact, we'll take the temperature of this water when we're done to see. You can see it's boiling pretty good. Those bubbles are boiling. See, it's getting deeper. Boiling pretty vigorously now. This is using ice. See how deeply it's going? It's going right down to the bottom of the tube now. So think about why that's happening. Why would it boil? Okay, this is, you could say it's directly related to Gay-Lussac's law, but you could also say it's the combined gas law. When I put the ice on the beaker, okay, I dropped the temperature of the gas, the air inside that beaker. When the temperature drops, it also affected pressure, so the pressure also dropped. That pressure, in a sense, becomes like the atmospheric pressure over the water in there. Remember, water has a vapor pressure. So we discussed last unit. So when the vapor pressure of the water is equal to the pressure of the gas, it'll boil. Right? So the cooler we make the air, the less pressure it has, and we can keep boiling water at lower and lower temperature. Oh, it's starting to slow down now. And really, based on dynamic equilibrium between liquid and gas, there is a slight change in volume, especially initially. So that's where the combined gas law comes in. Some of the water becomes vapor, but eventually it goes into equilibrium, and then there wouldn't be a volume change. I need that thermometer. Okay, so now we're going to take the temperature of that water, see at what temperature it boiled at. And we were below 40 degrees Celsius, and we were boiling. So right around 40 degrees Celsius, because the pressure of the gas was that low.